Okay, good afternoon, everyone, and welcome back to this new version of the workshop on commodities and macroeconomics, co-organized this time by the Central Bank of Chile and the Central Bank Research Association. I apologize for the delay in joining you. I was at a board meeting, which is always a risk with central bank governors, but fortunately I was able to finalize that meeting and then join you. For us as the Central Bank of Chile, it's a pleasure to host this event, which has contributed to disseminate high quality research in a topic that is extremely relevant for emerging countries and particularly to our own, in the light of the relevance of copper in our economy, and of course for other countries in the region, other commodities. But we have all been discussing about the commodity super cycle, and that will be the topic for our keynote address by Martin Uribe. Martin Uribe is very well known in the central bank and the academic community. He's a professor of economics at the Columbia University and the research associate of the National Bureau of Economic Research. Before joining Columbia, Martin taught at Duke University and the University of Pennsylvania and was a staff economist in the Division of International Finance of the Board of Governors of the Federal Reserve System. He has made scientific contributions in the areas of international economics, monetary economics, and public finance, which have been published in academic journals, including the American Economic Review, the Journal of Political Economy, and Econometrics. So without further ado, I'll leave you with Martin Uribe and his keynote speech entitled "Does the Commodity Supercycle Matter?" based on a paper that was co-authored with our colleague Andres Fernandez and Stephanie Schmidt-Grohe. So Martin, please, the floor is yours, and it's a pleasure to have you with us.
Thank you very much, President. It's an honor that you're here. I would like to thank the organizers of this meeting for having me, and especially the Bank of Chile for hosting us. I know that it has been an enormous effort to adapt to these new conditions, so that is really something that I'm very grateful for. So let me put on my slides. This paper is joint work with Andres Fernandez from the Bank of Chile and Stephanie Schmidt-Grohe. Both of my co-authors, I believe, are here in the conference. So they are invited to jump in if they have any comments to make. The motivation for this paper is that there is a literature out there that talks about commodity price super cycles, which were characterized that way because researchers realized that commodity prices, real commodity prices, displayed long and persistent cycles along with shorter cycles. So these longer cycles are known as commodity price super cycles. The literature has focused mostly on characterizing the amplitude, length, shape in general, the turning points of those cycles, but there's less of a body of work on the contribution of those cycles or of the underlying shocks that are responsible for those cycles in explaining movements in aggregate activity at the country level. Therefore, the present paper's objective is to, first of all, identify transitory and more permanent shocks that drive both regular cycles in commodity prices, the commodity price supercycle, and to ascertain what is the role of those shocks in driving the business cycle at the level of individual emerging and developed countries, with an eye on the importance of the shocks that drive the commodity price supercycle. So that is the main focus of the paper. The way we identify the commodity price supercycle deviates from the bulk of the existing literature, which has focused mostly on spectral analysis. So basically, what the literature has done is to take, for instance, one commodity price, do a spectral decomposition of the variance of that price, and take certain bands, say 20 to 50 years, and look at that portion of the spectrum. Now, that literature, what it finds is that, well, first of all, it has to do one super cycle per commodity price. And the result in that literature is that all super cycles, or the super cycles of all commodity prices, are highly correlated. So we're going to take that result as suggesting that what the data seem to be asking for is for a common driver of the commodity price supercycle. So we are going to therefore identify the commodity price supercycle as a common permanent component in the main real commodity prices. This has the additional advantage that it creates a natural habitat to analyze the effect of these shocks responsible for the super commodity price and of other shocks, for instance, more temporary shocks, in explaining aggregate activity. So let me show you how we do it. Before doing that, let me talk about the related literature. So I divide the related literature, which is very extensive when it comes to terms of trade shocks and commodity prices, into large groups. One that is very specific about commodity prices, and in particular about super cycles. Then there is another, that literature has, as I said before, mostly focused on spectral analysis, but it has also used factor models and HP filtering even. Then there is a literature that talks about the effects of terms of trade shocks and commodity prices on aggregate activity in general, without dividing or conditioning on whether the underlying shocks are the ones responsible for the super commodity cycle or regular shocks. And that literature is typically divided into two. There is a branch of the literature in which an international real business cycle or variations thereof is used as the basis for, or as the laboratory for, analyzing the impact of these world price shocks. And then there is another literature that is more agnostic, that is more less structural, is more of a VAR literature in which these shocks are evaluated in a more flexible environment. And finally, there is a literature also on how important are transitory versus permanent shocks in driving business cycles in emerging and developed countries, which is related to this literature precisely because the shocks that drive the commodity supercycle are supposedly of a more permanent nature. So that literature is naturally related to what I will be talking about today. Okay, so what are the elements of the model that I will present today? It's going to be an empirical model, which is going to have a foreign block. That foreign block is essentially going to consist of 12 world prices, 11 of which are going to be commodity prices, real commodity prices, and the other is going to be the world interest rate. Now, this model is going to contain these variables in the trended form. The same with the domestic block. The domestic block is going to be concerned mostly with explaining output at the level of individual countries. So we're going to have 24 countries. And output is also going to enter in the model in stationary form, in the trended form. These variables are going to be driven by world shocks, which are going to be of two types. Are going to be stationary and non-stationary world shocks. The non-stationary world shock is going to be the one responsible for the commodity price supercycle. And then individual countries are also going to be driven by domestic permanent shocks and transitory shocks. Now, the problem is going to be, as I will show it in a second, that trends and shocks are not observed. So we don't observe the trended variables. We don't go and do HP filtering or anything like that. We assume that we don't know the trend, because the trend is driven by these permanent shocks, which are the object of our analysis. So we are going to treat the model as a model in terms of latent variables, and we will exploit the fact that the model does have precise predictions for variables that we do observe in order to uncover the likelihood of the data. The model that I'm going to be discussing now is going to be casting quarterly, the quarterly frequency. The data is going to range from 1960 to now, basically, I think it's 2018. And we will apply Bayesian methods. So let me move right away to the foreign block. The foreign block is going to have these 11 real commodity prices that I call P1, P2 until P11 plus RT, which is the world real interest rate. And I will assume that each of these prices is, commodity prices is non-stationary, but that there is a variable that I call here XPT, such that a stochastic variable, exogenous stochastic variable, such that if you subtract XPT from any of the commodity prices, the resulting variable, which I'm going to call P hat T, so P hat 1T, P hat 2T, and so on, is going to be a stationary variable. Okay, so the real commodity, all real commodity prices are co-integrated with this common component. This component, as I will show you, is going to be the one associated with the super cycle in real commodity prices. The real interest rate, we are going to assume that it's stationary. We could have used a specific permanent component for the real interest rate, but it doesn't, although I know that there is a long discussion around the world about the stationarity of the real interest rate. The truth of the matter is that if you put it over a long period of time, you don't get much out of that permanent component, the real interest rate. So for the sake of having the model parsimonious, we're going to do away with having a permanent component there. And then we are going to assume that these stationary variables, the hatted variables, which are the stationary versions of the prices, this is the equation at the bottom here, evolves according to this autoregressive process that is driven by two types of shocks. One shock I already explained is the growth rate of this trend, of this common trend, delta XPT, which is itself an exogenous random variable whose law of motion I'm going to specify in a second, and a stationary set of shocks, ZPT. You should interpret this as world shocks that affect commodity prices that are stationary in nature. Okay, so there are two sources of variations of these world prices: the non-stationary world shock responsible for the super cycle, and these stationary world shocks denoted ZP. The domestic.
Excuse me, Martin.
Yes.
There are a couple of questions, clarifying questions from Martin Sturmer. Yes. What are the commodities in the sample? Metals, food, energy?
Okay, so we have 11 commodity prices, and they are, for instance, in food, you have beverages, agricultural materials. It's at that level of is the pink sheet of the World Bank disaggregation. So you have fertilizers there in that category. Then in the metals, for instance, we have gold, we have platinum, we have silver. In the energy, we have oil, gas. There is one more, coal, and so on. So for those of you who are familiar with the commodity price subdivisions of the World Bank, is the subdivision that gives you 11 commodity prices, which is the one I just mentioned. Okay.
And also there is a question by Pablo Garcia about the sample. Are all the 24 economies small open economies, or there are also advanced?
Yes, yes. So I will divide I will present two data sets. The first one is going to be quarterly. We require for a country to be included at least 50 years of data because of the focus of the theme of the paper. So our sample goes from 1960 to 2018, and that, if you want quarterly data on output for all of those variables, that is to say output and real commodity prices, you need to focus on a data set that is mostly OECD countries. So the analysis that I'm going to do now includes mostly small open developed economies, right? So you're going to have the usual economies in Europe, all the periphery of Europe, the United Kingdom, all the Scandinavian countries. You're going to have Australia, New Zealand, and then there will be a few countries that are now OECD countries, like Mexico, but you also will have Turkey, you will have South Africa, but the sample for the quarterly data is going to be mostly biased towards developed small open economies. Then we're going to extend this set of countries to allow for emerging countries. For that, we will have to go to annual data, and I will talk about that later. Is there any other question?
Martin Sturmer asked again, why did you not choose metals that are more closely linked to the business cycle, like copper, zinc, etc., or are base metals also in your sample?
I believe that those are in a category other metals. No. Yeah, I think it's in metals. We have precious metals and metals, so we don't have that disaggregated. There is a trade-off here that has to do with the fact that every single real commodity price you add, you lose degrees of freedom. So we had to make a compromise, and we thought that having metals, precious metals, but I agree that maybe a robustness check, which I don't have, in which you replace, say you aggregate precious metals and disaggregate other metals in the way that was suggested, would be a very interesting way to go, precisely for the reasons that the question mentioned. That is to say that there could be metals that are now aggregated into metals that are good predictors of the cycle, like especially for some emerging countries, like, say copper or Chile. Any other questions?
No, I'll let you know if there's another.
Okay, thank you. So the domestic block of the model is similar to the foreign block, except that the variable of interest on the left-hand side, if you want, is going to be real output, the trended real output that we define as y hat t, and y hat t for country I is going to be real output itself minus a stochastic non-stationary variable, which is going to be country specific, which we are going to call xi such that if you subtract that variable from output, you obtain a stationary variable that you could refer to as the trended level of output. And that is going to be country specific. So we will have 24 of those trends, one for each output. And the evolution, the law of motion of output is going to be as given here at the bottom of this slide. So real output is going to be autoregressive, and it's also going to depend on past values of the real commodity prices, plus it's going to be driven also by shocks of two types. The foreign shocks that I already introduced, changes in the commodity price trends, the stationary world shocks, changes in the domestic trends, these are going to be domestic trend shocks, and domestic stationary shocks that are going to be embodied in these country-specific shocks, ZIT. Those are going to be domestic stationary shocks. Now, notice that we could have taken an alternative approach here, a slightly different approach, which is to include the contemporaneous commodity price vector on the right-hand side. Notice that as it is now, all the commodity prices on the right-hand side are lagged. We could have included the contemporaneous price and do away with the foreign shocks on the right-hand side. That is to say, do away with delta XPT and ZPT. The reason why we decided to do it like this, to have XPT and ZPT on the right-hand side and only lagged values of the price on the right-hand side, is that we want to have the flexibility that these world shocks affect individual small open economies in ways that are not mediated by world prices. Examples are, for instance, regional productivity shocks or global productivity shocks that could have effects both via prices and outside of the price system. That is to say, more direct effects, such as in, for instance, country-specific technologies. So I think this specification is more flexible in that sense, and that also makes sense because the purpose of our investigation is really to ascertain what is the role of this delta XPT and the other shocks, ZPT and the domestic shocks, rather than assuming that it's the prices that are driving business cycles. What is driving the business cycles here are the shocks, and the prices are just mediators. Okay, so summing up the model is presented here. This is the entire model. So we have two blocks: the foreign block, the domestic block. The foreign block is kind of the system is recursive in the sense that the foreign block is, if you want, autonomous, and then the domestic block feeds from both domestic shocks and the foreign shocks. Nonetheless, it is important if one does, for instance, Bayesian estimation, to estimate the model jointly, because having the domestic block is informative about the foreign block, right? So even though the system is recursive, estimating the model jointly provides information that would not be used if one estimates the system block by block. So the way we are going to estimate this model is going to be jointly using Bayesian techniques. Now, these driving forces, which are the trend shocks, the growth rates of the trend, domestic and the commodity price trends, delta XPT and delta XT, and the stationary shocks, the ZPs and the Zs, are going to jointly be distributed in an AR1 form. So they're all going to follow an AR1 process, and we're going to assume that these AR1 processes are all univariate. Okay, so as specified here by the law of motion of the vector ut that encompasses all these driving forces. Okay, so now these two equations that compose this model cannot be, or three equations if you include the driving forces, cannot be taken to the data directly because nothing is observable. We don't observe the detrended variables because we don't observe the trends. We don't observe the shocks. We don't observe essentially any variable in this system. So we cannot jump directly to using data to estimate this model. So we need to exploit the fact that this model provides predictions for some variables that we do observe, and then make a link between the variables we do observe and the variables of the latent variables of the model to be able to calculate the likelihood of the data. And what we are going to exploit is the fact that this model has precise predictions for, oh, I'm very sorry. I want to tell you one more thing here about the domestic block. We are going to assume that these outputs are co-integrated not just with the domestic productivity shock, but potentially also with the foreign permanent commodity price permanent component, simply because in a small open economy, these shocks, in any model that you may write, will in general have an effect on output. And if the shock is non-stationary, it is likely to have a non-stationary effect on output. So but what we are going to do is to include enough flexibility to be able to estimate how strong that trend component, this foreign trade component in domestic output is. So we are going to estimate these alpha i's at the country level. There will be one alpha per country. Okay, so what predictions of the model are we going to exploit to link observables to unobservable variables? Well, for instance, the growth rate of the commodity prices. We are going to assume that we can observe the growth rates of the prices. We take the data, we take the growth rate of those commodity prices, we can observe it, we have data for that. Well, the model says that the growth rate of a commodity price is the growth rate of the detrended version plus the growth rate of the trend. So there we have one identity that links an observable variable, the growth rate of prices, with two unobservable variables, which are the detrended variable and the growth rate of the trend. And the same for the growth rate of output. We are going to assume that we do observe, could be with some measurement error, but we can observe the growth rate of output. And there is an identity that says that the growth rate of output is the growth rate of the trend output plus the growth rate of the trend, which has these two components, the domestic component of the trend of domestic output and the foreign component of the growth rate of the domestic output. So these identities are going to be useful for ascertaining what is the likelihood of the data. Okay, so when we estimate the model, what do we get? The first thing that I want to show you is what does the shock that drives the super cycle in commodity prices look like in the data. So we do this by smoothing out, using the Kalman filter, this permanent component in commodity prices, this XPT, which looks like this. So what I have here is the permanent component XPT, which, remember, is common to all commodity prices. And I also plot for comparison the commodity prices themselves. And what you see is that this is basically a smooth version of the commodity prices. Now, the interesting thing about this permanent component of the commodity prices is that it has a shape that is very similar to the super commodity price cycle estimated in the rest of the literature, which, as I told you, uses mostly spectral analysis. In particular, as you can see here, this variable XPT, this permanent shock XPT, has two peaks, one in 1980, around 1980, and one in the early 2010s, which coincide with the oil crisis and basically the recovery from the Second War. Run up to the peak is the recovery, and that ended with that oil crisis in the 70s and 80s. And the second peak has to do with the accession in the early 2000s of China to the World Trade Organization and the emergence of China as an important international trading partner for many countries around the world. So what that gives us is comfort in the sense that we are detecting a shock that drives the super cycle that is pretty much in line with what we see in the related literature. And the nice thing about that, which is the second advantage that I mentioned at the beginning of my talk, is that this was extracted in an environment that makes it very natural to ascertain what is the role of this shock in driving business cycles in these countries. Okay, so what I have here is the variance decomposition of the different commodity prices and the share in the variance of these commodity prices of this permanent shock XPT. And what this table says is that this permanent component is an important factor in driving these commodity prices. On average, it explains 1/3 of the variance of these commodity prices. In the case of oil, it explains the majority, more than half of movements in the price of oil. And that you can see, if you allow me to go one slide, sorry about that. If you allow me to go one slide back to this graph also shows you with the thick broken line, the price of oil. And you see that of all commodity prices, the price of oil is one that moves particularly closely with this permanent component of commodity prices. So that is therefore not surprising that here it shows up explaining a large fraction of the variance of commodity price. But on average, it is an important driver of commodity prices of about 1/3. I don't want you to focus. This is the import response to an innovation in XP of the different commodity prices. And here, I don't want you to focus on any particular price, unless you are an expert in a particular price. You can take a look what happens with your price. But what the point of this graph is to say that the typical pattern for more than half of these charts, what happens is there is a permanent increase in the this driver XPT that in the long run goes to 1. So all prices have to respond by 1% in the long run. But some prices increase, most prices increase by less than 1 initially, and then in the long run converge to 1. And some prices overshoot. For instance, oil overshoots and converges from above. And some prices have a delayed overshooting. For instance, gas. Okay, so you have basically the 3 types of responses. Most of them are of the more natural type, where it increases by less than 1 and converges to 1 in the long run, but there are some prices that overshoot and others that overshoot with a delay. This is perhaps the most important table in the paper. It shows the variance decomposition of output at the country level. And of course, this variance is spread across the 3 types of shocks. The world permanent shock, XPT, which is the focus of this analysis, the stationary world shocks, the permanent domestic shocks, and the transitory domestic shocks. Here, the list of countries is not exhaustive because they didn't fit. I put only every other country in a list ordered alphabetically so that you have a random sample of countries. But the takeaway of this table is 3. First, that if you add up world shocks, that is to say XPT and ZPT, they are very important, right? When you disaggregate them properly, they play a big role in explaining business cycles in these countries. Even though these countries are developed countries, they are not emerging countries. I mean, they're mostly developed countries. These world shocks seem to play an important role. Now, the point of the table is that much of this role played by world shocks is given to the stationary disturbances, not to the shock responsible for the commodity supercycle. The great majority of the variance of output at the country level is driven, is explained by the transitory world shocks. So that is the main theme of this paper, that although the shock responsible for the commodity supercycle is important, it does not play the dominant role. We have to continue paying close attention to what happens to transitory changes in the commodity prices, the commodity price of copper, oil, gas, and so on. Those transitory components are very important for understanding variations in output at the country level. The third point that one can make out of this table is a contribution to a long discussion on whether business cycles are driven by transitory or permanent shocks. So here what we are doing is adding the effect of the X's, XP and XI, and the effect on one side and the effect of the Z's, ZP and ZI on the other. And the message that transpires from this table is that, at least for these countries, the transitory disturbances seem to be explaining the majority of business cycles in this country. So 3 takeaways. 1, world shocks are important, very important for business cycles at the country level, but the importance is mostly given by variations in transitory shocks and transitory world shocks. And third, overall, business cycles seem to be driven primarily also by transitory shocks. This result also extends if one looks at larger horizons, which is interesting because those are the larger horizons are the natural habitat, if you want, of the shocks driving the commodity supercycle. So naturally, if one extends the horizon, the importance of permanent shocks is mechanically or partially mechanically, speed at which it's going to increase, at which when you increase the horizon, it's not mechanical, that is an estimation. So when you increase the horizon to, say, 30 years, the importance of the permanent world shocks, the XPT, this has many countries. Again, you just should focus on the mean if you want to. I don't want to make you dizzy with so many numbers. I just put the countries there because this is a world conference, and I thought that you might want to look at your own country just for curiosity. So I put all the countries there, but what I'm going to say is here mostly talking about the mean. The main result that I made, I referred to in the previous chart, extends to this forecast error variance decomposition across different horizons. The importance of the permanent world shock increases, but not by much. It continues to be the case that even at long horizons, the transitory component of the world shocks plays a dominant role. So this commodity price super cycle is driven apparently by a shock that is important, but that does not play the dominant role. That is the main takeaway also from this forecast error variance decomposition. Okay, so I want to leave some time for questions. So I'm gonna, is there any questions? Sorry, I forgot the rule that I should stop a little bit to ask for questions. Is there any question at this point?
There are, but we can leave them at the end if you want.
Okay,
So
yeah, that would be.
We can open the discussion at the end.
Okay, that would be fine. Thank you very much. So this is an input response, which again, I put all of the countries for just because there's no other way to show it. But what I want to tell you here, these are the input responses of output to an innovation in the permanent component of commodity prices, so to XP. And this is a permanent shock, of course. And what I want to point out is that for most countries, the effect is a negative effect. So output falls. And that is not surprising because these are mostly developed countries. So they're not producers of primary commodities. They're mostly users of primary commodities. So it makes sense that an increase in those prices are contractionary. But even if the country is a net exporter of a commodity price, remember that this shock is the common component of all commodity prices. So when you have an innovation in XP, all commodity prices are going up, not just the one you export. So to the extent that the economy uses these commodities as inputs, they will have contractionary effects. But even there's even another effect that could be contractionary, which is if you're an exporter of commodities and there is an increase in commodity, in a permanent increase in the commodity prices you export, that might generate a positive wealth effect that might have negative effects on the labor supply, and that might have a contractionary effect. So there are many reasons why the increase in output could be negative, or the change in output could be negative in response to a permanent increase in commodity prices. When I extend now shortly the sample to having more emerging countries, you will see that this is turned around. So when you focus on emerging countries, the effect is mostly positive. So I'm going to do that real quick so that we have some time for questions. So the way we are going to include emerging countries is by going to annual data. It's impossible to construct a rich data set with many years, say at least 50 years of data with many emerging countries at a quarterly frequency. So what we are going to do is we're going to make some sacrifices. We're first have some time aggregation. We're going to go to annual data. And second, once you go to annual data, the number of data points you have decreases. So we are going to further aggregate the number of commodity prices from 11 to 3. So we're going to have 4 world prices, which are going to be 3 commodity prices and the world interest rate. And the way we're going to do it is going to be having metals. It's going to be one category. Non-metals is going to be another category. And I guess energy, right? Yeah, so those are going to be the 3 categories: metals, non-metals, and energy. And I'm going to very quickly, more or less, go over what I did before. This is just confirming that the commodity price super cycle, or the path of XPT, which is the shock, the permanent shock responsible for the super cycle, looks similar to what we had before, in the sense that first is a smoother version of the true prices, and second, it has these 2 peaks, one in the 80s and the other in the early 2000s. So that was reassuring to us, and that gave us the impetus to keep going with this. This is the importance of the XP shock in explaining commodity price changes, the variance decomposition of the commodity prices themselves. And you see that it's even more important than the quarterly data. This is to some extent mechanical, because we are aggregating across time and across commodities. So we are killing a lot of, by simple aggregation, we are killing a lot of room for these transitory shocks to play a role. So, but the result is that remains is that this XP shock seems to have an important role in driving commodity price changes. Now, when it comes to explaining output movements, the same result we had with the developed countries and with quarterly data extends to the case in which we have in the sample also a large quantity of emerging countries. The role of commodity of this XP shock, the permanent component in commodity prices, has gone up a little bit, but it continues to be that the dominant role is played by world shocks that are temporary in nature. So the result basically remains for emerging countries that world shocks taken together are very important, but that the majority of these, about 2/3, is taken up by transitory components of those world shocks. The permanent component of world shocks plays a non-negligible role, but it's not the shock that is responsible for the commodity price supercycle does not play the dominant role. Okay, there are 10 minutes left for the end of this session, so I want to leave them for questions. So I'm going to end with this slide and some conclusions. This slide is also the input responses in the set of emerging countries that we have in our data set of output to an innovation in XPT, an innovation in this permanent component of commodity prices that drives the super cycle. And what you see here now is that the dominant pattern is an increase in output, which again, the intuition would be that since we have moved here to the set of emerging countries, it's likely that these countries are producers of primary commodities, and as a result, an increase in all commodity, the permanent component of all commodity prices could have a positive effect. Okay, so as I said, I want to leave some time for discussion. So let me conclude here. The primary purpose of this paper is to identify the shocks responsible for the commodity price super cycle. We do that by identifying it with the permanent component of commodity prices. We first make sure that the identified super cycle looks like the super cycle that is estimated in the related literature. And then we place that in a model that is suitable for understanding or characterizing its importance for driving aggregate activity. And what we find is that the shock that is responsible for the commodity price super cycle does play a role that is non-negligible, but that role is not the dominant shock, that we still have to be very attentive, especially in emerging countries, to innovations to commodity prices that are stationary in nature. Okay, so I'm going to stop here to open the floor to questions. Thank you.
Okay, thank you, Martin. We have 3 questions so far. So Felipe Safi will be asking first. Francisco, can you open the microphone for me?
Okay, Felipe. Thank you, Martin. This was a very thought-provoking paper, and I have basically 2 questions/comments. So the first one is, have you explored what happened when you allow different groups of commodity, for example, energy, metals, and agriculture, to have their own cycle, their own permanent trend component? And in that case, you would have different loadings for different countries, just like in your other paper with Stephanie and Andres. It could be that they are loading differently on these baskets, and you're smoothing too much this permanent component by allowing it to be common. So that's the first question. And the second one is, I understand your results as at business cycle frequencies, output seems not to be driven by trend shocks to this common commodity component. But that doesn't imply that this permanent component from the common commodity cycle doesn't drive output at lower frequencies, because that could even be consistent with your results in forecasting errors at longer frequencies. Basically, what I'm thinking is, if you have low frequency cycles in GDP, would those low frequency cycles perhaps be correlated with the low frequency components of the common commodity cycle? We know that for the exchange rate, it seems to be the case. The question is, could that also be the case for GDP? Those are my 2 comments. Thank you.
Okay, thank you very much for that question, Felipe. And needless to say, my co-authors, Andres and Stephanie, if you want to jump in anytime, feel free to do it. So I think the 2 questions are related. You have to walk a thin line here, because perhaps the most important result of the existing literature on super cycles is that commodity prices have super cycles that are highly correlated. So you cannot play too much with, and if you look at the graph that I had, the first graph where I plotted all the commodity prices together, you look at them, and in the long run, they never depart from one another. They seem to be, sometimes they get a little bit apart, but on the long run, they seem to be moving in a pack. So if you put their independent trends, you are going to mess up that graph. So the way we try to walk that thin line is by allowing this permanent component to have different loadings for different countries at the domestic level. So each country has a different loading on the commodity price, plus its own non-stationary shock. And what we find is what you saw in the biggest table that I showed you, which is the forecast errors at different horizons, that it is true that when you look at long horizons, the role of this shock that is responsible for the super commodity cycle increases somewhat. It never takes a dominant role. You have to really look at extremely economically irrelevant long horizons of, say, 400 years to start seeing some dominance of these shocks in driving output growth. So I think that is the kind of constraints that you face when you put this data together, right? When you try to nail not just the permanent component of commodity prices, but also the permanent components of the individual output at the country level.
Okay, so we have a couple of minutes. There is a question by Martin Spurmer. Francisco, can you open the microphone?
Okay, Martin.
Yeah, can you hear me?
Yes.
So I have two questions. One, and thank you so much for this great presentation and for organizing the workshop. I have two questions. One is, I was a little bit surprised about the sample of countries that you have. So why are countries like Germany or the United States or Japan that have kind of large industrial sectors, why are they not included here? And then the second question was kind of thinking about the case of Chile. I mean, my sense is that the business cycle in Chile is strongly affected by copper prices. So how would you, I mean, how do you kind of view, for example, the case of Chile through the lens of your model? Would these shocks kind of be driven by ZP here, by these transitory world shocks? If there's a shock to the copper price? Thanks.
Yes. So with respect to the first part of, or the first question, first of all, thank you very much for those questions. Is that we deliberately excluded large countries because we wanted, the model we have is one that works if the country is a price taker. If the country is not a price taker, then you have a lot of endogeneity on the right-hand side. Say if you have the United States, domestic shock will in general affect world prices and so on, and you would have to do something about that. So deliberately, we focused on a set of countries that we thought were small. So we took out the United States, we took out the Chinas, and so on. With respect to the example that you gave of Chile, I should have perhaps given the conference taken a little vignette and analyzed in more detail Chile. That would have been useful. But so let me talk about the representative country in the sample. You are exactly right. I mean, what the predictions of the model are saying is that it's not that the world shocks are not important. They are, when you consider them jointly, important. And it's not that the shock responsible for the commodity super cycle is not important. It is important, but it does not play the dominant role. That is all that it is saying. So that when a policymaker in an emerging country or a small developed country considers how these commodity prices should enter in the policy debate, should focus not just on these shocks that are responsible for long movements in commodity prices, but also for the transitory shocks that are driving commodity prices on a quarter-by-quarter basis, on a year-by-year basis, because they take the lion's share of the movements in aggregate activity.
Martin, if I can just complement very quickly on Chile, given that we have the majority of the audience from this country. In Chile, the numbers that we get are along the lines that you were saying. We get close to a third of the variance decomposition of output growth is associated with these world shocks. But again, the lion's share of that, close to 20%, is coming from these transitory shocks.
Right, thank you. That's for that.
The last question is from Benjamin Garcia. Francisco, can you open the microphone?
Okay. Benjamin?
Yeah, do you hear me?
Yes.
Yeah. Well, it's basically, I think, very similar to the second comment of Felipe, that, I mean, as you are only allowing for only one single common non-country specific factor to explaining the different GDP trends, and that factor is restricted to be the same as the common commodity trend, maybe the estimated factor is not only capturing that pure commodity trend, but other many non-commodity global super cycle. So I don't know, maybe it's more on the interpretation that is just a general, like you use in your conclusion, just a general world non-stationary shock that gives all those impulse response, and not necessarily a commodity shock. I don't know if your specification allows for the differentiation.
No, thanks a lot for asking that question, because it allows me to clarify. I was, throughout my presentation, I think in the paper as well, we are careful not to talk about commodity price shocks. We always talk about shocks that are responsible for movements in commodity prices. So this could be any shock that is permanent in nature and that drives the commodity price super cycle. We don't think that there exists such a thing as a commodity price shock. Commodity prices are endogenous objects that respond to underlying sources of uncertainty. So it is true that XPT could encompass a variety of permanent components, permanent components in weather, permanent components in perhaps certain policies in core countries in the world, correlated permanent components, etc. But they are not shocks that are attached to prices per se. The prices respond or mediate those shocks as they transmit to emerging countries, but they are not the origin of those shocks.